Let me quickly introduce our first speaker. His name is Naveen, and he's been in the tech for the past 10 years or so. He's worked across massive companies like Target, Flipkart, and LinkedIn. Currently, he's working as an architect at Salesforce. And he's like while we were discussing this for the CFP, I actually saw him coding the UML diagram, guys. So that's Naveen. Let me quickly introduce him. Hey, Naveen.
Hey folks, my name is Naveen. It's been more than 2 years since I've been a tech talk of this kind of an audience, so I'm a little rusty, so please bear with me. I have experience more than 2 decades now, and somewhere in the mid part of my career, I realized that as software developers, we work hard and we don't work smart enough. So over the years, I figured out techniques of working smarter, and I've been sharing my knowledge in different forums, and today is one such instance. Yeah. Theory without practice is empty, and practice without theory is blind. This quote strongly resonates with how I think of software development and how I develop software. I'll share this presentation. I can look at my LinkedIn profile and my Medium page where I post my ideas. Couple of disclaimers. I'm speaking on my personal capacity. My views don't always represent my employers. Some of the pictures I'm using in this slide deck are from Google searches. This is the high-level overview of the agenda. I'll talk about qualities of software. I'll define them. I'm going to present a meta model. I will list a bunch of qualities which are not well known, and I describe the relationships between these qualities in the ontology. Folks, any point in the presentation is a good time to ask questions. The word quality has multiple meanings in English. One meaning is we describe how good something or how bad something is. Similarly, we describe attributes or characteristics of people or things. This has carried over into software development as well. By quality, we talk about how good the software is or not. And we also refer to characteristics of software. There are two different meanings. In this presentation, I'm going to be referring to the second meaning. I'll try to make this interactive. What are the components of an electric wire? Okay. Why copper? Why not gold? So copper and gold both are good conductors. Copper is cheap, gold is not. Similarly, plastic is a good insulator and cheap. This is the reason why we use these in electric wire. So one of the things I want to promote in this talk is thinking from the lens of qualities. There are slightly different meanings of quality and quality attributes. This is what I'm going to be using in this tech talk. Qualities is what software has, irrespective of whether the stakeholders want them or not. And some authors exclude functionality as a part of qualities. I am not. And coming back to natural language, there are we use things like height as qualities, and we also refer to things like short and young and fat as qualities. I'm going to be using them interchangeably in this talk. So both height Unshort and tall can describe a quality in my model. How many of you are familiar with meta models? Okay, meta models are models of models. A good metaphor would be XML and XSD. You can write an XML which conforms to an XSD, but XSD itself has a structure, a set of constraints and rules. So the meta model is equivalent to Adobe XSD, while models are equivalent to XMLs. You can have mutually exclusive qualities. You can have qualities, one of which can be a cause and can affect. Effects can be two types. The cause can increase the effect, or the cause can decrease the effect. Other relation is the one between dependee and dependency. The dependee requires dependency for it to be viable. I have a few examples. So somebody can be overweight. Obese is being overweight and more. Typically, it means there are some health conditions. I'll talk about composition, rich and famous. Somebody who's rich and famous are rich and famous. I wanted to spend a minute over here. Obese has more characteristics than overweight, but rich and famous has exactly what rich and famous are not. I've spoken about it. So someone can be big and small, and mutually exclusive qualities. If something has strength, it is likely it is durable. The more the strength is, the more durable it can be. Okay. Folks, if you look at a piece of code designed on architecture, the more understandable the code is, the more maintainable it will be. Agree, disagree? And more maintainable it is, the lower the cost of operation. Agree, disagree? Many concepts in software development are fuzzy. One such concept is of system design. The first paragraph here is what I copied from Wikipedia. System design is supposedly application of system theory to software development. So, this tech talk, I will be viewing software development from the lens of systems. And what is a system? A system is a group of interacting or interrelated elements that act according to a set of rules to form a whole. Systems are everywhere. They can be as big as a solar system and as small as the molecular system. They can be human, they can be man-made, they can be application software, and so on. This is a UML diagram, not to be confused with the meta model I am talking about. A system can be composes of multiple parts. These parts can have interdependencies and they can interact with each other. This again is a UML diagram. All information systems are systems. All software are information systems. And I'm referring to something called a software system. A software system is a composite of humans and software. So some of the qualities I'll be talking about will be here, some here, some here, and some here. So this is a dinner set. Together, they allow somebody to have dinner. But you can think of the spoon, the fork, the saucer as atomic constructs. They're not systems by themselves. Human body is a good example. We have multiple systems within. Each of them have parts, relationships, purpose. But they come together to form a uber construct for a human body. This type of a system is called system of systems. Sagar was talking about how this company grew. So, as the number of employees in a company increases, would they continue to report the same CEO or will there be more levels of hierarchy? Why? Why? The fewer the number of people each person has to interact with, the better the communication is. So if you think of these are the parts of a system, as the system grows in size, it makes sense to make it narrow and not broad. Similarly, the responsibility of each part increases. Okay. Question for you folks. Given an array of integers, how do you find the fourth largest element?
You can integrate.
Okay.
You can do dividing it. You can do sorting of the integers.
Okay. Let's go with the sorting approach.
You can make a number of others.
No, let's still stay with the sorting algorithm. Would you keep the sorting algorithm within your find code, or would you keep it as a separate method? Why? Besides reuse,
It's a two-way reuse. It's not a main problem.
Shifters.
It's altogether a different system.
okay. Suppose this is another example. You have a composite method which has been broken down into sub methods. All of you gave good examples. The sort algorithm can be reused. Do you agree with me if the original algorithm, the original method would be easier to understand if you extract the sort as a separate method? So, as the system becomes narrower, it becomes more understandable. Understandability increases the maintainability. Understandability reduces the cost. Also, the number of concepts in your system increases. Instead of saying find fourth max, you have find fourth max plus a sorting method. With me so far? Okay. I'm going to talk about two other properties, emergence and effectiveness. In the world of medicine, they use two different measures to quantify medicines and treatments. One of them is efficacy, and one of them is effectiveness. How well does the medicine perform in a control set versus how well does it perform with a more diverse set of subjects? To draw a parallel with software, efficacy can be thought of how well it performs at a point of time for today's requirements, while effectiveness can be thought of how does it perform over a larger time horizon. You can think of efficacy as a part of effectiveness. Now, effectiveness itself can be categorized into two subparts, deliberate and accidental. In the find max 4, we wrote a sort method and extended it out. The intent was not to write a sort method to start for. As a part of your solving, we wrote a sort method and extracted it out. So that is more accidental effectiveness. While you can have a deliberate where you start assuming features which may not be required go ahead and start building them. Now, somebody spoke about reusability. As you have a sort method, you can apply it in future use cases. Something like that would increase the agility of development. So the takeaway here is accidental effectiveness helps in agility while keeping the cost low. Let me go back to a real world example. How far you travel in a car depends upon how much fuel you have, as well as how economical is your driving style. So think of it as this is the number of units of fuel. This is how far you want to go, and this is how economical your driving is. Both of these factors together influence the number of units. As you want more functionality, the number of concepts in your system increases. Similarly, as you become more economical, the number of concepts in your system decreases. Now let me speak about the other property, emergence. Emergence occurs when an entity is observed to have properties its part do not have on their own. I'll come back to this. How many of you have played Tetris? So the parts which make Tetris are called tetrominoes. Now, you can combine parts in different ways to get something like this. So, it is difficult to extrapolate what kind of structures can you compose with tetrominoes to start. You can see stuff, you can see shapes emerging with time. You can think of emergence as a special type of effectiveness. I can use them with 1 bit. 0 represents the first value, and 1 the second value, and so on. Both of these representations allow me to capture what is required, but they're using different amount of information. So if you go back to this, the 0, 1 represents 0, 1 value and 1 formula. How would my code deal with 1 or 0, 0? Error. The takeaway from this slide is that compact representations or economical representations tend to avoid faults. How many of you are familiar with the tally system? We use it for counting cricket scores. It's a very simple concept. You keep adding strikes, and whenever you get 5, you put a cross. This is a very, very simple system. Compare that to the Roman numerals. 1 represents, I represents 1, 3, 5, and so on. And compare that with the decimal system. This 5 represents 5,000, this 5 represents 5, this represents 3, so on. Consider doing this multiplication using tally system or the Roman numeral system. It will be hell. So going back, economy is something which we do today in different forms. When we normalize database tables, it is exercising the economy property. When we apply the don't repeat yourself principle, we are striving for the economy property. When you strive for economy, you increase the reusability of it. By doing so, you are reducing the cost of software development. You are increasing the fault avoidance. You are increasing the agility, the maintainability, efficiency of your code. Do you know how many keys, how many locks can you open? And how many keys should a lock be open? Few. One of you. Again, going back to how many of you familiar with generics in Java? So this allows different kinds of lists, list of integers, list of strings, and so on. Genericity is a type of parametricity account. So let's consider two different sort methods. The first one takes an array of integers and sorts them. The second one takes a parameter. If it is true, it sorts in ascending order. If it is false, it will in descending order. This has more parameters and hence it has more power. The reusability of this piece of code is going to be less than this piece of code. By making your code parametric, you're increasing its economy as well as its reusability. Folks, in the context of COVID, this might be an interesting example. So, there are two ways of greeting each other, one with handshakes and one with fist bumps. Why do we do fist bumps? Lesser contact compared to a full handshake. So, it is still physical contact, but it is limited. So, there is coupling, but I'm trying to quantify the amount of coupling. So imagine a puppeteer who has a puppet which has lots and lots of strings. Beyond the first 2 or 3, the puppet becomes difficult to manage. So this is again from Wikipedia. Coupling tells you how two pieces of software, two pieces of information are connected. But we strive for limited connectiveness and not more connectedness. Also, why do we use interfaces? More. Why?
This is normally defined as that you can have different activity. You're defining that model.
Abstraction. Abstraction, the word abstraction is derived from the word subtraction. You are taking away something. It is a minimization of the contract. By reduction in the contract, you are again reducing the cost of development, testing, and all of these things. The number of pieces of software each software element interacts with is a form of coupling. The richness of the contract is a form of coupling. The number of interfaces a piece of code exposes is a kind of coupling. The number of interfaces, the size of each interface is also a form of coupling. So, as coupling increases, the cost should increase. Ignore the damage. Okay. What if there were no rules on roads? Like the one in Bangalore. Why?
People will do what they want to do without caring about other people.
Okay. Why rules? What does rules buy us?
Control, respect, and order. I would say instead of taking rules as a negative thing, like controlling something, I would rather take it as of as a standardized, like giving a direction for everybody to follow.
Two parts to your I'll on the second part. By making rules, it makes it predictable for everyone. It reduces now the number of information somebody has to deal with. Hence, rules increase the fault avoidance and which is type of reliability. Okay. What happens if one side drives on the left hand side and other side drives on the right hand side? Both are following the rules. Yes. So just having rules is not sufficient. The rules have to be consistent with each other. Such as quality is what I'm calling as order. Orderliness is a good property to have for your systems. Folks, will continue with the driving metaphors. This is a road with few cars, but it's uneven both in terms of width and elevation. This is a road with few cars, but it is smoother, uniform width, uniform height, and so on. This is a road where the clear do's and don'ts on when you cross, how many lanes are there, when you can change lanes, and so on. And this is simple. So, folks, based upon this, I categorize this into 4 different buckets. The number of elements, few or many. Is the system orderly or not orderly? I call this simple, complex, complicated, and heterogeneous systems. To go back to the petrol example I spoke of, you require more liters of fuel to travel far, irrespective of how efficient you are. So, as the number of vehicles increases on a road, you have to go to this side. Drawing a parallel with your software, as your company grows, as you get more clients, as you add more features, you will go from the left to the right. Going from being on the top or the bottom is a choice we have as developers. So, folks, one of the challenges I've had is simplistic systems are not functional. They don't provide agility, maintainability, understandability, and all of those things. Nor should the system be complicated. The only option we have to build sustainable systems. Okay. A lot of terms in software and natural world are overloaded. I think that this principle is still not disagreeing with this. This principle cannot be applied at the cost of correctness, not at the cost of understandability. So, folks, I really want you to take a head on.
Tiny factor in this conversation. Like, when exactly are you taking the decision? For example, you just started a product, okay? You just started building a very new product. You don't want to be neither complex nor complicated. You don't even know whether you're going to get the traffic or not. You're just experimenting. So you would just like to work with a simple tool, having a API, a controller, and you use API and data. all the design principles to be implemented. Design factor.
Vishwas, how many lines of code you require to make a call of being complex or complicated? How many lines of code has to be there in your system for you to take the call of pursuing modularity or pick?
I don't know, like, let's say,
No. Make it judicious call.
you're asking for the lines of code.
Yes. Number of concepts in your software system. Each line, each object, each method call is a constraint.
Yeah.
At what point would you want to say this is I require it, this model?
So the way I feel about this is, I would not just look at the code. I would look at the business that is coming.
I mean, a different call. What I'm saying, if you're writing code, you're writing a lot of lines of code. At what point would you consider I want to modularize my code?
Exactly. That time thing which I am talking, right?
I'm not taking about time. I'm taking a different perspective. What point would you say the code requires to be modular?
Yeah. So that one I'm saying. That will depend on what kind of business I'm getting.
No. Take away business. Business is a whole different thing.
Okay.
For me, that number is 100. 100 lines of code cannot be complicated. You spoke about UI, API, and controller. That itself is modularity. I have a different talk on this today. But these choices need not be macro. They can be as simple as 100 lines of code. In the final max code, which would have been maybe 10 lines of code, 20 lines of code, we chose to modularize that next time.
Which is why, like, your view is different than me because the factor, the unit which you are taking to measure that particular thing is the lines of code. I am not thinking that way. My measure is what kind of like the value.
Go back to the earlier slides. I spoke about how making things orderly, constrained, make things agile. You are compromising on the long-term cost for optimizing for short-term cost. And the premise is that it is counterproductive. With a 10-line program, we chose to break down two pieces. Iterative approaches, using domain-specific languages, and so on. You are making and developing systems where heavy lifting is done by software and not the humans. Folks, I give an example of two sort methods. Sort which does not take an argument, another which takes ascending order. So based upon the last parameter, the code will sort in ascending order or descending order. Similarly, you can externalize configuration saying that software can do this or that based upon some information. Instead of developers creating sort for ascending, sort for descending, the software can be done to do different things based upon configuration. Folks, this is a snapshot of properties as spoken so far. There is a very, I want to follow up on modularity with the topic for this one. Any questions?
Ravi, short time, if you have any question, please with the while we are having tea, coffee, and snacks break. Thank you so much, Naveen.